Okay, so powers and roots. We have already looked at just converting from trig form to rectangular form and vice versa. We also looked at multiplying and dividing complex numbers in their trig forms. Today we're going to look at, can we raise a complex number in trig form to a specific power, and can we take a root of a complex number in its trig form? So we're going to start with the powers piece, and we're actually going to derive the formula together. I think it will be helpful for that formula to kind of stick with you. And this is the formula you have to bring to the test. So it's knowledge that you're required to know for the test. So we're going to derive the formula together. I'm going to start with just like multiplying a complex number by itself. And we're going to see if we can uncover a pattern here. So I'm going to start with some z, some complex number equal to r cos theta. I have it written out on the screen as r times the quantity cosine theta plus I sine theta, but I'm going to abbreviate it as r cos theta from here on out. In math, what does it mean to square a number? Take a number and multiply it by itself. So on the second line where I have z squared, let's take z and multiply it by itself. So z times z, or r cos theta times r cos theta. And then use the multiplication rule that we looked at with, I can't remember who asked that question on the homework assignment. Or 57, who was that? Okay. And then with Paige, we did division, okay? But think about those rules from Friday. What do you do with the two modulus here? Multiply them. So what's r times r? R squared. And then what do you do with your two arguments? Add them. What's theta plus theta? 2 theta. So to square a complex number in trig form is going to be r squared cos 2 theta. Let's look at what happens if we cube a number, complex number in trig form. So to cube a number, we're taking the same number times itself 3 times. We've already multiplied it by itself 2 times, so I'm going to bring down my z squared, r cos 2 theta. In order to get z cubed, I just need to multiply it by itself, r cos theta, one more time, right? So it's like r cos theta times r cos theta times r cos theta. Same rule applies. Multiply your modulus. R squared times r is r cubed. Add your arguments, 2 theta plus theta, 3 theta. Because we're multiplying the same complex number by itself, theta is the same angle each time, so I can actually add those. Okay. Are you noticing a pattern? Okay, in your mind, predict what you think z to the 4th is going to look like. We'll work it out just to verify that that's actually working, and then we'll write a rule. Okay. So I'm going to do z to the 4th next. There's 2 ways you could do z to the 4th. You could think about it like z squared times z squared, or you could just do z cubed times another z. Okay, so either way you work it out is totally up to you. I'll do z cubed times another z. Ooh, yeah. Times another complex number z, multiply my modulus, add my angles. Is that what you thought it was going to be? Okay, now write the rule for z to the n. This is the rule you bring to the test on Friday. You know this rule.
Scrumpy.
This is Miss Grumpy. Good, how are you? I do. Sure. Abigail, you're supposed to take your stuff and head to the front office. Share with your pods, what did you get for your rule? Does it look something like this? R to the n, kiss, and theta? Okay, so that is the formula for multiplying, or for, sorry, not multiplying, but raising a complex number in trig form to a power, n. Okay, now, on the next slide, I have this written out formally, like you would see it in a textbook. Okay, so it's the same formula. There is a little bit of stuff there up at the top that just clarifies z is a complex number, and you have to raise it to a positive integer n, so we're not raising it to negative numbers. Okay, and you might add to your formula that you have down there. If you're going to leave it in trig form, your angle should be between 0 and 360. Okay? This would also be really important if you start with a problem in rectangular form, and then you want to do the work for raising it to a power with trig form. Make sure that you got the right angle or right argument for the right quadrant. Okay, so make sure it's an angle between 0 and 360. Let's do a couple of quick examples. We're going to do one in each form. So what if I give it to you in rectangular form? What if I give it to you in complex form, or sorry, trig form? Here's our first example. Negative 1 plus I to the 6. Okay, you have the formula right above that on your notes. I've got that written down right there in the top corner of my slide. And we need to calculate raising negative 1 plus I to the 6th. We're looking at the formula that we just sort of derived by patterns. What things do we need to know? R, theta, and n. Okay, how will you find any of those things? Sure, this is like your warm-up, right? You have something in rectangular standard form. So this looks like a plus bi. And that means that b is 1. And you've got to get theta, the argument, so you're going to use inverse tangent. What quadrant is that point plotted in? Quadrant 2. So when this spits out negative 45 degrees, then we should add 180, and we have 135 for our argument. All right, how will we find modulus? Think about your warm-up. The square root of a squared plus b squared. So we're going to do the square root of negative 1 squared plus 1 squared. That's the square root of 2. N, what's n? 6. It's whatever you're raising the complex number to. Okay, so it's like your exponent. So now that we have all three of those things, we're ready to plug into our formula. So I'm going to say z to the 6 is equal to the square root of 2 raised to the 6 kiss 6 times 135. Now, if I wanted to leave my answer in trig form, then I should kind of simplify a few of those things. What is the square root of 2 raised to the 6th power? 8. If you do the square root of 2 times the square root of 2, you get 2. And then you have 3 pairs of 2's, right? So 2 times 2 times 2, you're going to get 8. And then, what is 6 times 135? 810. Now, if you were leaving it in trig form, we would simplify that by getting like a coterminal angle that's between 0 and 360. So 8, 10, you're going to have to subtract 360, still too big. Subtract 360 again, so you're really subtracting 720. And you're going to come up with z to the 6 equals 8 kiss 90. Now, Nicole had asked me the question before class started, just a little bit confused about, do I leave it in trig form or do I put it in the rectangular form? The book in the back for your homework assignment previously was kind of switching back and forth. And I just said to her, if it says specifically what form it wants it in, then yeah, I need it in rectangular form or I need it in trig form. If it doesn't say specifically, you could take your pick and both answers would be right. So you might leave it in trig form, or you might think, since it starts in rectangular form, maybe I want to go back to rectangular form. So if I want to go back to rectangular form, then I've got to do the work, right? So 8 times cosine of 90 plus I times sine of 90. That's really 8 times, what's the cosine of 90? 0 plus 1i. So then we're going to come up with 8i. And this would be in rectangular or standard form. Now, there are other ways for you to do negative 1 plus I times raised to the 6. You could actually multiply it out 6 separate times. But think about all that expansion you have to do. Remember when you did your roller coaster project in semester 1? You had like 6 different zeros, and you had to just keep multiplying and keep multiplying and keep multiplying. It got really big. So that would get kind of messy. And then if you used like the shortcut, the binomial expansion theorem with like Pascal's triangle, that would work out, but you'd have to worry about all your cycles of I at the end. Like if you had I to the 7th, you'd have to reduce that. That's the same as I cubed, which is really negative I. So you'd still have a lot of work there. But this is actually pretty nice, okay, compared to those two methods. Okay. Let's do another one. This time I'm going to give you the complex number in trig form. So you can, in your notes, you can write it out like I have it, or if you want to write 3 kiss 60 raised to the 4th. It's the same thing. And then see if you can plug into your formula. Find what you need, plug into your formula. I'd ask that you, on this example, give me trig form and rectangular form. Let's practice both ways. Kind of nice when it starts in trig form because then you have everything you need for your formula, right? You know your modulus is 3, you know your argument is 60, you know your power is 4. So like I said, while you're calculating there, do it in trig form, and then also get me an answer in rectangular form. Did anybody plug those cosine 240 and sine 240 into their calculator and get decimals? Yeah, can you tell me what the first one is? Negative. And then what'd you get for the next one? So on these problems in this section, if you're doing powers and roots, I'm totally okay with you giving me decimal answers. So if you want to like skip the unit circle piece on these, I'm okay with that. Okay. So if you gave the negative 81 halves minus 81 squared root 3 over 2i, that's okay. That works perfect. That's an exact answer. But I'm also okay in the rectangular form if you just do the cosine 240 in your calculator and multiply it by that 81. And the sine of 240 in the calculator multiply by 81. Reason is on my next examples, we're going to be doing to find the roots, we have to do the formula several times. And so it's kind of a lot of work to like be thinking back to the unit circle. So I just say for powers and roots, you have a free go to just use your calculator and give me decimal answers. Any questions on this? Okay, next up is roots. We're going to take the roots of complex numbers. Here is your formula. This formula is provided for you on the test. So what you'll see is the formula. You'll need to know how to use the formula. So I'll just give you a moment to jot things down, and then we'll talk about what it all means. Okay, for a positive integer n, the complex number z equals r cos theta has exactly, we can barely see it, n, sorry, it's off the screen, n distinct roots. So if you're taking a cube root, how many roots will you have? 3. If you're taking a fifth root, how many roots will you have? 5. Okay. Well, those will be the distinct roots, and I'll talk more about that once we do one of our examples. But note that for these problems, when you're doing roots on your test on Thursday, you'll have to repeat the formula numerous times so that you get the correct number of roots. How will you know how many roots you're supposed to have? Based on what root you're taking. A square root would have only 2 roots. Okay, okay, so we've got z sub k, and this is like my root. Okay, so I'm going to have like, if I was doing a cube root, I would have 3 z sub k's. I'd have z sub 0, z sub 1, and z sub 2. Then I'm going to do the nth root of r, kis, theta plus 2 pi k all over n. And there's my k again, right? So when I do z sub 0, I'm going to plug 0 in for that k. When I do z sub 1, I'm going to plug 1 in for that k. Z sub 2, plug 2 in for that k. And that's going to get me my different distinct roots. Now, if I have a problem that gives me radians, I'm just going to use radians. If I have a problem that gives me an argument in degrees, you can work in degrees. You would change your formula then to be plus 360k. So whichever, I just work with whatever angle they give me. I don't really mess around with conversions. I can either add 2 pi k or add 360k. Cute. Yes. So if we're in 2 pi k, then we got to change into radian mode. Okay, so if you want to jot that down, that would be good thing to write. Say radian mode. And then here you can say degree. Where k is 0, 1, 2, dot, 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 and minus 1. So how far that goes up in the list just depends on how many roots you have, right? If we were doing a fifth root, 5 minus 1 is 4, so we would do k is 0, 1, 2, 3, 4, and that gets us our 5 roots. If we're doing a square root, then n is 2, 2 minus 1 is 1, so we would just do k for 0 and 1, and that gets us our 2 roots. Okay. Let's look at this in work. Find the cube roots of 8 kiss 2 pi over 3. Okay, I'm going to jot down the formula that we had. This gives me an angle in radians, so I'm going to work with radians. So I'm going to use my plus 2 pi k, which means at some point I'll want to change my calculator into radian mode, so maybe you do that right away. And then think about all the things that you need to plug into this formula. What do we need? Well, we need to know r, which is 8. What else do we need to know? K. How many, or what root are we taking of this? The cube root. So the cube root then implies that n is equal to 3. So now we also know n. And that means we have to do k for what numbers? 0, 1, 2. And we have n equals to 3. We also need theta is 2 pi over 3. Okay. Now, some people may change that to 120. I'm not going to mess around with that. I'm just going to use my radians. Okay. Not scared of radians. All right. So I'm going to do my first root. Z sub 0 equals cube root of 8 kiss 2 pi over 3 plus 2 pi times 0 all over 3. I just sub in all those little pieces. For me personally, once I get that first root written, I just do all my roots after this, changing k. So I'm going to go ahead and do my other 2 roots. Z sub 1 is going to look exactly the same. Cube root of 8 kiss 2 pi over 3 plus 2 pi, and then here I change from 0 to 1, because my k is now 1. Divided by 3. And then I do that one more time. Z sub 2 equals cube root of 8 kiss 2 pi over 3 plus 2 pi 2 all over 3. Are there any questions about what I'm doing? Where my numbers are coming from? How I'm getting things? Okay. So next up, I would kind of simplify things. So I'm going to simplify that theta plus 2 pi k over n piece. On the first one, 2 pi times 0, that's just 0, right? And then I have 2 pi over 3 divided by 3. That's like 2 pi over 3 times 1/3. So that whole angle is going to simplify to be 2 pi over 9. Okay. So I can simplify this. And what's the cube root of 8 out front? 2. If it comes out nice, you could reduce it. If it's not a nice number, I'd just leave it alone. Like the cube root of 9, I would just leave as cube root of 9. But I can say this is 2 kiss 2 pi over 9. Okay, so I found that first root in trig form. Now I do the second root in trig form. Okay, I've got to take 2 pi over 3 plus 2 pi. So it's like 2 pi over 3 plus 6 pi over 3, that's 8 pi over 3. So 8 pi over 3 divided by 3, that's going to give me 8 pi over 9. 2 kiss 8 pi over 9. And then I got to do it one more time. This time I got to do 2 pi over 3 plus 4 pi. So I'm thinking 4 pi is the same as 12 pi over 3. So 2 pi over 3 plus 12 pi over 3, that's 14 pi over 3 times 1/3, which is 14 pi over 9. And these are the 3 roots in trig form. Now, I'm going to show you visually what we're talking about right here. Okay. So I'm going to plot those 3 roots. And remember that R is 2, that's your modulus, right? It's like your absolute value, your distance from 0 for the complex numbers. So that means all 3 of these roots land on a circle with radius of 2. Like any point on this circle would be modulus 2. Do you agree with that? And then the angle, the argument, 2 pi over 9, 8 pi over 9, 14 pi over 9, that just tells me where my point actually is. So think about 2 pi over 9, that's somewhere in the first quadrant, right? Okay. So here is maybe 2 pi over 9, this is going to be my z sub 0. 8 pi over 9 is just a little bit less than 1 pi. So it's probably somewhere in my second quadrant. There's z sub 1. And 14 pi over 9, well, 9 pi over 9 would be 1 pi. And then there's still 5 pi over 9, which is a little bit more than a half. So it's probably somewhere in the fourth quadrant, z sub 3. Or sorry, z sub 2. My third root, but I call it z sub 2. And each of these roots have the same distance from the origin, a distance of 2. And can you see how around that circle they're like evenly spaced? Okay, like a Trivial Pursuit piece, little pie pieces are all even. That will always be true if you ever graph your roots. They'd be evenly spaced. So if you were doing a 5th root, you'd have 5 evenly spaced points around a circle with that same modulus. And then the reason why the definition of that formula says distinct roots is because if you'll remember, like with the cycles of I, we could keep going around, so we could have another root. It will just be the same as z sub 0, because if we go the same even distance, we're going to keep landing back on these points. Okay, so there's 3 that look different, so you could have more roots for the complex number. Now, what if you wanted rectangular form? Make sure your calculator is in radian mode and evaluate. So if you wanted the rectangular form, you're going to do like 2 cosine 2 pi over 9. Okay. So if I were to do 2 cosine 2 pi over 9, I get 1.53. And when I do 2 sine 2 pi over 9, I get 1.29. Think about on this, I'm going 1.53 to the right and 1.29 up. I probably didn't graph my first point very well there for 2 pi over 9. I'm kind of off, but it'll work. Okay. And then z sub 1, I'm going to change my angle to 8. So I get something like negative 1.88 plus 0.68i. And then I still do 14 pi over 9. So my last one is 0.35 minus 1.97. I am plugging in, I'm doing my trig form, so like for this last one, z sub 2, I'm doing 2 cosine 14 pi over 9. And then I do 2 sine 14 pi over 9. And that's where I'm getting my decimals. This is Miss Cronky. Yes. Yeah, I'm sorry, we were all wrapped up in a problem. He forgot to go. He's packing up. Hugh, you scared us all. It's all Hugh's fault. Your heartbeat's racing right now. I'm doing 2 times cosine 14 pi over 9. And that gets me 0.35. And then on a separate one, I do 2 sine 14 pi over 9, and that gets me negative 1.97. Yeah. Maggie. No, for z sub 1, I'm doing 2 cosine 8 pi over 9 and 2 sine 8 pi over 9. And for z sub 0, 2 cosine 2 pi over 9, 2 sine 2 pi over 9. That's how I'm getting those decimals. Any other questions? Yeah, Hugh. What? Yeah, yeah. Now, I do just want to say one quick thing about one of your homework problems. It's set up a little bit differently. It says find the 5th roots of 1. So think about finding the 5th roots. That means that n is equal to 5. And then, like for the number 1, that's really 1 plus 0i. So could you find r and theta? Yes. R equals the square root of 1 squared plus 0 squared. So 1. Theta equals the inverse tangent of 0 over 1. So 0 or pi, because it's positive 1, it would be 0. And then you can use the formula. Okay. So if it gives a problem in standard form, just think about your warm-up in the first example we did. You find modulus, you find argument. So you do have a homework assignment. Make sure that you do your homework assignment. Tomorrow at the beginning of class, you'll work in your pods to do an activity together. And you want to be a helpful member of your pod, so you got to know where to start a problem. If you